In this example, we're given EPA water samples for lead levels that show a mean lead level of 0.02 milligrams per liter with a standard deviation of 0.005 milligrams per liter. And we want to know here what level corresponds to a sample that has a population z-score of 2.2. So we're given, this is population data. So we're given our mean is 0.02, so that's going to be mu equals 0.02. And then our standard deviation 0.05. So for population, that's sigma. So sigma is 0.005. And then we're given the z-score of 2.2. And we want to know what level. So we want to know x equals what. So we'll start out with our z-score formula here. So z is x minus mu over sigma. And then plug in what we know. So our z here is 2.2. Our x is what we want to find. Our mean, 0.02. And our standard deviation, 0.005. That goes in the denominator. So we want to solve for x, so we'll multiply both sides by 0.005. So on the right-hand side, those guys cancel. On the left-hand side, 0.005 times 2.2, that is 0.011. If you plug that in the calculator, equals x minus 0.02, and then take this -2, bring it over on the left as a positive. So 0.02 plus our 0.011 will equal x. So that's going to be what, 0.031? So that's the x value that is 2.2 standard deviations above the mean. Now, just to get a feel for what's going on here, let's look at how these z-scores look in relation to the distribution. So if we are assuming that this is a mound-shaped distribution, your x bar or mu here is always in the middle. That corresponds to a z-score of 0. So our mean was 0.02. And then you add standard deviations going to the right. So this is going to be mu plus sigma, mu plus 2 sigma, and mu plus 3 sigma if you're talking about population. So we're adding 0.005. So this way is going to be plus 0.005. So this would be 0.025 and then 0.03, add in another 0.005 and then 0.035. And then going the other direction, mean minus 1 standard deviation sigma, mean minus 2 standard deviations 2 sigma, or mean minus 3 standard deviations 3 sigma. So this would be subtracting 0.005, be 0.015, 0.010, and 0.005. So those are the x values that correspond to z-scores of -3 through +3. So we're seeing that the 0.031, that falls in this interval, be about right here. And you can see that's between a z-score of 2 and a z-score of 3, and our z-score was in fact 2.2. So that's making sense on the distribution. So when you have mound-shaped data and you're looking at z-scores, you should always have this picture in mind of the distribution, where mean is in the middle, add 3 standard deviations, subtract 3 standard deviations.